Hello guys. So our deployment has been done. So let's check out our deployment which we have done in the previous lecture and see how we can access the everything. So as you can see, you can what you have to do is just after logging into this, just go to the resource group like this, and then select your resource group which we named as a course group, right? In the course group, you will see the another blade which says that overview. Click on the overview and then click on the deployments, right? Click on this deployment and then you will see the number of deployments, and then click on this Microsoft Azure blockchain and click on this. When you click on this, you will see these outputs, right? These outputs are important and we need to access this. So first you need to do is copy this and open it in a new tab. When you open a new tab, what you will see is the interface Ethereum node status, right? You can reload whatever you want and you will see that latest block number will keep changing. Means the network has started mining, right? And these are the peers which are available to the others, right? So for example, for this mining 4, right, network, this is seeing actually the 4 peers in the network. Remember that one server may or may not see another peers, or we can see a different number of peers, right? So this is all done. So this interface means that your blockchain has been set up properly. Now what you need to do is we need to check out the Ethereum RPC port. You know, the Ethereum RPC port is endpoint is the URL where you will be hitting the the HTTP request for the accessing the the APIs. So as you can see that JSON RPC 2.0, it is properly working. Error code because we didn't send any request properly. But yes, this endpoint is responding with this. It means that this is working properly. So if I'll just zoom it, so this is working properly. So now we have this Ethereum node status where it is showing everything is working properly. So this two means admin side and the Ethereum RPC endpoint. These are the actually two things. But and the last part is this, the SSH to do the SSH into the first transaction node. So I'm going to copy this. I'm going to do the SSH right now. So I'll open terminal, right? And then when you see the terminal, all you have to do is I'll just zoom it, right? Go and paste this whatever you have just got from the interface. So I just copied this and I'm going to put enter. It will ask me if I need to add this in the elliptic curve. So I just added. Now it is asking for my password. Remember my we have set up a password for the SSH. Yes, so we got the SSH. So we are now have logged in into the first transaction node, right? If you do the listing, you'll see all the files are available and everything is there. The Ethereum has been installed automatically. You don't have to do anything. All the Ethereum configurations are available here, right? And then all the get log, or you can say that Go Ethereum is a client in the Go language for the Ethereum network, so that you can use. So this is the get log. So whatever the log you want to see, if you want to see particular logs, you can see there, right? Okay, so we have this whole Ethereum up and running. All we need to do is now just test this network and see by actually transferring some assets from one place to another place. Remember, when this Ethereum node has been set up, the first Genesis block, or you can call it a first block or the Genesis block, has actually received 1 trillion ether by default. So remember, you have actually created a master account which owns 1 trillion ether right now, right? All you can do is transfer the ether to a particular new address just for the testing and do your experiments, right? So all this Ethereum setup and mining, everything has been configured automatically. You don't have to do anything here. So each consortium member is actually given a separate identical subnet containing one or more mining nodes, right? All these mining nodes are actually backed by a proper storage account where this storage is being created. So as you can see, if you go to the interface, you'll see that there is a mining server. This is a virtual machine, right? This is a mining 2, this is mining 1, mining 0. So each server has a storage as well. So if I check the storage, let me show you where is the storage. Mm, Where is the storage? This is a network security group. Each server have a network security group as well. This is a network interface card. This is a storage account. So remember, the each consortium has actually backed by a storage account. Means that there will be a different mining servers, but they will be actually using the same storage account. So there will be three different storage account because we have created three consortium, right? So so as I told you that all nodes have the uh, latest Go Ethereum client software and will be configured to be a mining nodes. So that has been done properly, and also that all the nodes use the same Ethereum address and the key pair that we protected by the Ethereum account password. So remember when we created the password, so all are actually using the same password. All nodes are having the same settings, and everything is same. So we don't have to configure each and individual. And about the transaction node, that all consortium members are members actually share a set of load balanced transaction node, because as you can see in this, sorry, in our PDF, that all the consortiums actually are actually connected to somehow using the transaction subnet. So they are actually sharing the transaction nodes. These nodes actually are reachable from the outside of the virtual network, right? So that the application can use these nodes to submit the transaction or execute a smart contract within the blockchain networks, right? So all the nodes have the latest stable Go Ethereum client software and are configured to maintain the complete copy of the distributed ledger. And these nodes actually use the same Ethereum account protected by the Ethereum account password which you provided, or we provided during the launching the setup. So we have explicitly separated the nodes that actually accepted the transaction from the node, and that mine the transaction to ensure that there are two actions and are not competing for the same resources. That's important. We also have a the load balanced the transaction node within the availability set to maintain the high availability. The template is this template currently support maximum 5 transaction node inside this subnet, so they cannot be more than 5. And about the Ethereum configurations and all, that there will be a pre-configured account containing the 1 trillion ether to seed the consortium network with the enough gas to handle the millions of transactions. That each transaction will need some gas, so that gas will be consumed from the pre-configured account which has the 1 trillion ether automatically. And since the mining nodes use this account, their collected fees feed back into the same account to ensure the continual funds. So that's going to happen. So as we have already shown you this, that this the admin page will look like this, right? So let's do the testing and transfer some ethers from here and there using the wallet and finish the course. So see you in the next lecture. Thank you.